Alright, let's start. Hello everyone, welcome to the stream. Today we will do some more texture mapping because, let's see, this is the state of the program as we left it from yesterday. We can change the width, height and depth. We can load a texture map here with this button. We can save and load the voxel grid. As you can see, loading does work, but we cannot change how the voxel, how the texture map is laid out. So if you look here, both of these texture maps have 6 faces, one for each face of a cube. But I might want to have different. Let's see, can I make this bigger? Can you scale, please? No. Alright, this is mega blurry. Also, the background is black, and this is not very useful. Well, I might wanna have texture maps where I have one single texture for all faces. So that's something that I have no support for yet. The code as it is actually can support it, but I can't make it do that from the menu. The GUI doesn't have an option to let me specify how the texture map's laid out, but we can actually have texture maps that are like that. For now, I think I will just I will hard code the texture map layout, because I'm not yet I don't know yet how to make a GUI for that is also usable, and I also don't know how frequently I will actually need that functionality to have different texture maps. Currently I only have the default texture mapping, which is initialized like this. It subdivides the texture map into 6 phases, which is, as I showed earlier, that's the default. The 2 texture maps are laid out like that. I will just make a exemption here for the hero voxel grid texture map. So we will just hard code it currently, and then I'm just gonna see how often I need to do this hard coding where I lay out the texture map in a specific way. If it's pretty frequent, I will make a GUI for it, and otherwise this should be enough. So basically, let's see. The hero texture map is just the sprite of the hero for its front face, and all other faces have just this black texture. Currently it's black, since most of the time you will only see the hero from the front, so the side views and the back views can stay black. The hero is also currently, let's see if I can show the sprite again. The hero is currently outlined black. Where is open width? Can I open this paint? I can. Since the hero is outlined black, the side views of the specific voxels can also be black. Yeah, so we will introduce the functionality to use something like this as a texture map. Since I am hard coding, I also need to know how what the dimensions of the front face is. Seems to be 12 by 8 by 12, 8 by 12 pixels, and the whole map is 12 by 12. So the front face, let's see, this is laid out like this. It has a texture field. Let's initialize that directly. Then it has 6 entries, one for each face at least. And the 0th is gonna be our front face. It's this guy over here. So he starts off at 0, 0 and is 8 pixels wide and 12 pixels high. But we need these pixel values in coordinate textures. So we need the inverse texture height, width, and the inverse texture height. Which is for both it's 1 over 12. Since we just said the texture is 12 by 12, and then we multiply this by the inverse texture height and the inverse texture width and height. And all other faces will just be this black part here. Which starts off at nine. Starts at the pixel offset 9, and it's 3 pixels wide and 9 pixels high. So it starts off at 9. And it's 3 pixels wide. And 12 pixels high. That's fine. This is a function call now. Let's see. I will introduce a couple of additional functions here for the texture coordinates where I can say that it should be rotated. How to do that? How the most awkward thing about these is to name them in a way that makes sense. So this is supposed to be counterclockwise rotated by 90 degrees, which just means that we are swapping. If I have texture coordinates, let's say that's my texture, the texture coordinates are laid out like this. Rotating these by 90 degrees just means, let's make this rectangular. So rotating this region by 90 degrees just means that we are moving the vertices one over to the left, counterclockwise. So if on the texture there was a T, if we render this with the rotated texture coordinates, it's gonna be displayed like this. So that's what this function is supposed to do. And rotating like this just means that the 0th index over here, the element with the index 0 will get whatever would originally be assigned to the element with the index 1. So we can just write this, and this should be enough. Similarly, we will have another version of this that is just clockwise 90 degrees, which is just almost the same thing, just the arrows are flipped over. So instead of this getting what would be in 1, it's gonna get what would be in 2 instead. Did I do this the right way? I don't think so. Let's undo this for a second. So 0 gets whatever would be in 1. So this becomes 1. 1 becomes 3, so that was wrong what I did before. 3 becomes 2. And 2 becomes 0. So it should have looked like this. So now reordering it becomes this. Right now a clockwise 90 degrees version. Let's redraw. So we have 0, 1, 2, 3. And clockwise rotation means this time we're gonna do this. So 0 becomes what would be in 2. So this is 2 now. 1 gets assigned 0. 2 gets assigned 3. And 3 gets assigned 1. Now reorder these. So these texture coordinates are now rotated by 90 degrees. And I'm gonna have overloads for these. Instead of taking a rectangular source of texture coordinates that take 4 vector 2's instead, and then calculate the rotated versions. So since we already drew the clockwise rotation, we're gonna do the clockwise version first. So 0 gets assigned 2. 1 gets assigned 0. 2 gets 3, and 3 gets 1. Like this. So rotating by 90 degrees basically is just swizzling the elements around. So if we reverse the direction of the rotation, this is counterclockwise now. So 0 is being assigned 1, 1 is being assigned 3, 3 is assigned 2, and no, 2 is assigned 0, and 3 is assigned 2. Yeah. So since I'm already doing this, I'm gonna have the mirrored versions also. Wait, how much did I copy just now? Let's just copy a single one. So this becomes mirrored horizontal. That basically just means 0, 1, 2, 3. That we are swapping the horizontal texture coordinates with each other. So 0 gets swapped with 1, and 2 gets swapped with 3. Let's take this one. So 0 gets what would be in 1. And 1 gets what would be in 0, and similarly this. So basically change this around. And if we mirror it vertically, just means we are swapping these around this time. So let's start off with the default case again. So 0 becomes 2, 2 becomes 0, 1 becomes 3, and 3 becomes 1. And if we reorder, looks like this. And then there is the third case where we mirror diagonally. So diagonal means we are mirroring around this imaginary axis. And that just means if this is 0, 1, 2, 3, we are just swapping these around. So this is the axis. So it's basically the same as mirroring horizontal ones and then mirroring vertical ones. So mirroring horizontal would mean we have something that looks like this, and then we mirror vertically and we end up with this. I guess we also need to swap 0 and 3 around. Yeah. Or do I? Let me think about this. If I just swap these two around, so let me think about this with a concrete example. So we have a T texture. If I just swap these with each other, the result will be this. Yeah, that's not the same as mirroring vertically, which would be this in this case. Since this is symmetrical horizontally, would just end up. Yeah, okay, alright. I convinced myself. So mirroring diagonally means this becomes this. So we are both mirroring horizontally and vertically. Wait, is this the default case? No. So diagonal 0 becomes 3, 1 becomes 2, 2 becomes 1, and 3 becomes 0. Then we reorder, and let's write these again where the argument is this thing. Let's move this up. What's missing? These versions, alright. Horizontal, we have 0, 1, 2, 3. Horizontal means this. So we are swapping the horizontal neighbors with each other. So this becomes like this. So 0 becomes 1. 1 becomes 0. 2 becomes 3, and 3 becomes 2. Swapping vertically means we are swapping these around in this direction. So we are turning this upside down, basically, the texture. If this was a T, it looks like this at the end. So 0 gets swapped with 2, and 1 and 3 get swapped. So the result is this ordering. So 0 becomes 2, and 2 becomes 0, 1 becomes 3, and 3 becomes 1. And diagonal means we swap in both directions, once in the horizontal direction, then in the vertical direction. So we combine these two. So we either swap these around, like this once more, or this once more, like this. So 3 comes here. This should be 1. No, a 2. Yeah. So this is 2 now, and 0 ends up here. So 0 becomes 3, 1 becomes 2, 2 becomes 1, and 3 becomes 0. Alright, now we can mirror texture coordinates and rotate them by 90 degrees in either direction. So now I can finish this one. How are the texture map faces laid out? Let me see. So front first, then left. Left is correct. Then the back. So we are gonna copy this for the back face. The right face is just a copy of the left face. The top face will be the rotated version of the right face. And the bottom face will be the same as the top face. We will be using this texture map. For the hero, okay, so then we need a way to assign the texture map. So tile mapping means if we go to the voxel state, let me see, there's a texture map. We will be changing the texture map to the default texture map. And if we click on the hero mapping, we will turn this into the hero map. And also we need to trigger the regeneration of the voxel mesh if we change the mapping, otherwise the changes won't be visible. Compile. A couple of bugs here. I guess in this case I don't need to do this. Alright. Now if I go here, there are two new buttons, one for the hero mapping, then the tile mapping. The tile mapping is just this particular mapping. If I press on this now, I meant this one. Yeah, this is gonna mess up the mapping because this texture isn't meant for the new mapping. This one is. And now our hero actually looks the way I wanted it to, although for some reason the top and bottom faces are see-through. That wasn't supposed to happen. Let me change the voxel grid itself to the right size. The hero is supposed to be, let's see. So let me open the texture here. Let's zoom in. The hero is supposed to be 8 pixels wide. So the width is supposed to be 8. And the height is 12. This is how the hero is supposed to look like. Let me remove a couple of voxels here that are unneeded. Yeah, there are a couple of see-through voxels here that I need to remove. I should probably make this automatic based on the texture map so it can remove voxels that don't get a texture assigned to them. Alright, this is how the hero is supposed to look like, except the bottom and top, the bottom and tops of the voxels don't have textures. So let's save this mesh. And then mess a little bit with the mapping. So rotating the texture coordinates by 90 degrees didn't work. Let's try the other one around. So 3 was which face? 0, 1, 2, 3, the right face. So basically we are turning this section, this section of the that section, this section of the texture map to this one. So it should be looking like this after that. Yeah. Let's load the hero. He has the wrong textures and the right texture map with the right mapping. And now he actually has the top and bottom texture coordinates. So I guess the problem is with the other version of this function that should be rotating counterclockwise. So let's see what the problem with that one is. This one. So rotating counterclockwise means if I have texture coordinates that are laid out like this, they are supposed to become, so we rotate counterclockwise like this. So it's supposed to be 1, 3, 2, 0. So the result is laid out like this. What do I have here? 0 becomes 1 is correct. 1 becomes 3 is also correct. 2 becomes 0. 3 becomes 2. That's correct. Why didn't this work? So the clockwise version does instead this. So the result becomes this. That's just the arrows inverted. Both do look correct to me. Zero is 1, 1 is 3, 2 is 0, and 3 is 2. Why didn't this one work? So if I change this to take the left face, will it then work? So this one should make any difference. No. Okay, what is going wrong here? The top and bottom faces are being messed up just because the top, if the top is messed up, the bottom will also be messed up. So let's check what happens. So the left face 0, 0. Oh, I was looking at the wrong thing. This is correct, this is correct, this one is correct. Yeah. And the rotated version looks like one zero, one one. So 1 0. Okay, and then 1 1, 0.50. Yeah, this should be completely black. It shouldn't be opaque, because this region of texture coordinates, they are referencing this black region here, this part. But OpenGL, for some reason, is it OpenGL's fault? These are looking correct to me. But if I use this version of the thing, the voxels don't have a top and bottom face. But if I use this version, where I rotate clockwise 90 degrees, it then works. Yeah, now it's correct. Well, let's just make the hero voxels. I guess he would look something like this. Maybe these voxels are too much. Alright, let's save it. Could make him look like this. Nah. Okay, this basically is the hero mesh now. Looks okay to me. We will now use that one for the hero when we're rendering him. So the game state will have an additional mesh ID, hero mesh, and a texture ID for the hero texture. Okay, game state. Oh, it doesn't have a initialized. Oh, here it is. So here we are gonna do the loading of assets. Where did I load the tile mesh? Probably here. No, not here. Load voxel mesh from file. Oh, for some reason I do that in the voxel loop. Even though I'm accessing the game state here, it doesn't have anything to do with voxels, except it uses the texture out of the voxel state. So instead of doing this, this will result in me loading this texture twice because I don't have texture caching yet, but that's fine, I guess. I could have done this just. This becomes make default. tile texture map. And then we have the game state hero mesh, which looks similar. Hero, and we use the hero texture map for that. We need to load the hero texture, which is this one. Now we should have the hero mesh correctly loaded. Let's compile. But we are not rendering him. Currently I'm rendering the player as a blue cube. Where is he? Render player, and here we have the blue cube. So instead we will do something similar to here. We translate the matrix by the player position, and then we render the hero mesh. That should be it. Right now, if I switch the view to the game map, game view, sadly the hero isn't getting rendered. So either this didn't work, or we didn't load, or we are not setting the texture. Game hero texture. Oh, there it is. Why aren't you falling? Also, why are your textures so messed up? You can move around very slowly. Oh, when he's falling, he's rising. So let me compare this code to how it was before. I inverted the player position before translating. So let's try that one out. And I multiplied it with the cell width. Let's I meant to do that. Alright. Now he's falling. He is hovering one tile above where he should be. And he can go into walls. He's still hovering. My changes didn't do anything. The reason the textures are messed up is I think I'm not passing the hero texture map. Here, yeah, it's the tile texture map, that's why. Yeah, now he's looking correct. He's still hovering. But I don't think he can now pass through tiles, maybe? No. That didn't help at all. I should be adjusting his position. Why does this have no effect if I multiply this by 20? It should have some effect. The hero should now be... Ah, so it does have an effect. Doesn't have the effect that I thought it would have. Oh, that's because this is supposed to be tile height. Tile height. Yeah, it's supposed to be tile height. And this is supposed to be tile width. Tile width was too much, but the tile height is good. Right, he needs to be 1 to around 5 voxels to the right. So let's try out so this means we're gonna push the position by 5 voxels to the left. I'm just realizing that I could have used my live code editing feature to adjust this. So that's 1 voxel too many. Whoops. 1 voxel too many. If I change this to 4 and recompile, he's now correctly outside. And let's check the right side. Alright, now he's not moving into stuff anymore. So how does this look if I enable... Oh. What happened there? Group is... Oh, okay. That's... I just broke the live code editing because I was using globals, pointers to globals, which I'm not supposed to do. So, okay, immediate mode, GUI. So if I generate a group, this function, it returns a pointer, but the pointer points to an array, to a field, to an entry inside an array inside a global. And if I reload the DLL, that global doesn't exist anymore, and that's why we got the access that error earlier. To GUI. So here I'm generating those voxels and I'm storing the pointers. So I'm not supposed to store pointers. Instead, we are gonna return indices. And we will be returning this value here, which is the index of the current group. And then if I need to actually do something with the group, we will have an accessor and I should assert that this index is inside the bounds and then I need to change this function. So instead of taking a pointer, it's gonna take an index. So let's compile. A couple of errors here. Oh yeah, GUI state. These need to be integers now. And we're compiling. Let's make sure that hot loading doesn't break the code anymore. Let's change something here. In the GUI. So I'm gonna call this something else. Recompile. Let's go into the menu. Oh, there's our E that I just inserted. If I remove it and recompile, something breaks. And the thing that breaks is the state of the global. isn't carried across the hot loading. So I need to change this. The state isn't allowed to be stored in a global. The state has to reside in the game code, but the accessor can be a global. So this can be a pointer. I'm just not allowed to have global state, and I'm not allowed to store pointers to globals. But globals can point to game data. So this becomes this. Now I need to change all of these dots to arrows. Alright, let's reformat the code. And when I bind, I'm gonna also pass in the GUI state. So the global will then point to the internal state, and we will be storing the GUI now, the state of the GUI as a field in the app data. This way the state will be also copied over when we do hot loading. Then when we are initializing, initialize app. Here we will initialize the GUI state. Default. Where is it? Not this one. This one. Default immediate mode GUI. And when we are reloading the app, this is where the rebinding happens. We will do this again. So the global always points to data that we have control over. So then this is a pointer now. And the bind takes the GUI state. Okay. So let's test this again. Now, while the game is running, I'm gonna change this one, recompile, and indeed it did update. And if this also works, it means, yeah, we got rid of that error. It's not breaking anymore. Funny bug there with the text. It's lagging behind the dragging. That's interesting. Even the buttons The other stuff doesn't lag behind, but just the text and the buttons here. Whee. Okay, that wasn't happening before. So let's add an to do here. When dragging a group, the title bar lags behind. And it seems to be one frame. I think. I'm gonna fix that later. I don't care about that bug that much. What I wanted to check was how lighting now looks in the game with the hero in there. Hero is kinda small when compared to the tile size. He's smaller than a single tile, which isn't optimal. So if the camera was this close, then it still isn't looking nice. So I need to make the hero bigger. The sprite is way too small. You should be at least 1.5 tiles big, I think. At least up to here. And the width is should probably be one tile, like 3/4 of a tile wide also. And the right side of these voxels shouldn't be black. Because looking from here, he looks segmented. And that's because the texture mapping isn't very nice at that point. Yeah, I need to change the texture mapping here for these 5 voxels. Yeah, otherwise, one other thing I think that's problematic currently is why. Oh yeah, the collision box isn't mapping correctly to the player, I think. No, this seems fine. So let me render the collision box on top of the player. This is the wrong file. Down here, this is the collision box. So if I disable depth testing here, and then re-enable depth testing afterwards, and make this see-through, Also, let's pick a different texture here. Alright, this is the collision box of the hero. No, it does seem to be fine. It's actually the right collision box. Yeah, it doesn't extend past the hero, since otherwise I would be able to see the hero, or more blue if I look like this. So this, yeah, this seems fine. So if I enable lighting, interesting, the opaque thing also is affected by lighting. Although lighting is kind of wrong. Interesting. That's because I disabled depth testing. That's why the ordering is wrong. Depending on from which side I'm looking, I'm seeing different faces. Yeah, it's because of depth testing. Alright, the collision box seems fine. One thing that's missing currently is jumping. Let's enable jumping. Let's see. Let's make these floats. We should probably only be able to jump if we are actually grounded. So if there is a valid index for the grounded tile, which means we are standing on a specific tile, only then can we jump. If we are airborne, that will be set to 0. So I guess since we are jumping, let me test out the version where I'm not doing that. Alright, so basically, whoa, that's a huge jump. Also, the gravity is kind of low. Hey, right, interesting. This does work. I didn't expect this to work, where the velocity gets reset immediately if he collides at the top of his head. And also this gap here is one tile big, and he can actually pass through there. Oh, there's a bug. Hey, we are falling through tiles. That's not nice. Oh, I know why that is. That's because I'm not handling in the collision code. Test point versus, where is it? Oh no, here. When I'm testing axis aligned boxes versus another axis aligned box, I'm not handling this case where if the boxes are already overlapping, I should be pushing one of them out. And I'm not currently handling that, so if I ever end up overlapping with a tile, so if the player for some reason ends up overlapping, the collision will just get ignored. That's why he was passing through the tile earlier. And of course now I can't replicate it. Okay, while I'm airborne, yeah, I can't jump repeatedly. That's good. Ah, there it was. Okay, let's try input recording. What were the hotkeys for that? P and O. Okay, so P records, O replays. So we go over here, we jump, and try to replicate that bug. Didn't work. Didn't work. Nope. So as I'm jumping, I'm hitting the record button and hope that the bug triggers, but it's not triggering currently. I think there it was, but I messed up. Okay, there it is. So now if I replay, yeah, we are triggering it every time. Huh. Even when replaying, the bug doesn't always happen. Interesting. Or there is a bug with the replaying. There is a bug with the replaying? Oh, I know what it is. I am using variable frame rates. So the input recording is tied to the frame rate, but since the frame rate isn't constant, when I replay, it doesn't result in the same thing. So I could fix that by, let me see, I could fix that by also recording what the elapsed time for that specific frame was. So when I'm replaying, I'm always passing in not the calculated elapsed time, but the elapsed time for that specific frame that I recorded. That way, that should be fine. So we are recording specific frames. These are the inputs for that frame and also the frame time. I guess this is elapsed time for that specific frame. What's more descriptive, elapsed time or frame time? Elapsed time. Oh, let's keep it as elapsed time. Okay, this should break the platform layer. So the elapsed time that I pass into the game is this value. So we will be moving this above the recording, which is over here. And then when we record, which is this here, we do this. And then when replaying here, we get the current frame again. We set the inputs to what the inputs for that frame are, and we will set this value to what we stored in the frame. So now when we are replaying, we are always passing in the same values as we recorded. This will result in slightly different frame rate when we are replaying, but it will be accurate to what we recorded. This is a double, it seems. It doesn't need to be double. Let's just make it a float then. It doesn't make sense to be a double. Then target time should also be a float. Since they are relative times, floating point accuracy is totally fine. Alright. Let's try recording again, and this time the bug should always trigger when replaying. But we first need to get the bug to trigger at all. Let's move a little bit closer there. Not triggering currently. Oh, there it is. Alright, now replaying, and it should be triggering every time. And it is, okay. So we fixed the frame time issue. So I guess using variable frame rate for the gameplay kinda sometimes breaks the collision detection. Okay, it shouldn't. So the way I did variable frame rate was I actually do use fixed time steps. So if the hero is jumping, his path might look like this. right? His paths are line segments that get updated at each boundary. Frame boundary. These are the points where his position, his trajectory gets updated. But the game time can be at any arbitrary point, so I can calculate the position of the player for this time, which will return this position. And then for the next frame, if only this much time has elapsed, I will then calculate this position. So even though the physics are fixed in the time step, the current position of the player can be in between frames. And it seems some bugs are only triggered in these in-between times. Okay, let's try to break and see what the problem is. I think it's because we are, as I said, we are encountering this case where we are overlapping and I'm not doing anything. Alright, where did I break? So I'm gonna change this code to output a message if this happens. Compile.